This is the lesson for Chapter 6, Section 1, circles. And so what we're going to take a look at is the area of circles, but we also need to be familiar with the circumference formula later on as well. So I'm going to take a look at the circumference formula right here. I've written it down for you. Again, circumference is the distance around the circle, and that is just the diameter, d times pi, and pi is just a ratio of the circumference to the diameter, and that can be found by, again, if I had divided by d here, to get pi all by itself, you see I have pi equals the circumference over the diameter. And that's how the ancient Greeks and Chinese mathematicians ended up approximating what pi is taking a circle, inscribing polygons inside of this circle, meaning inscribe being inside, and polygons have straight lines, and so they're able to find the distance around these polygons and then multiply or divide that number by its diameter, the distance across, and they came up with an approximation of pi. And so we have a pretty good approximation of 3.14. We'll use that when we're calculating these areas. And so our area formula is a little bit bigger, or a little bit more involved. We have to take pi and multiply it by the radius squared. And so that's what we're always looking for, is radius when we're trying to find that area of a circle. So let's take a look at our first problem here. It says, what is the area of the circle whose radius is 5 inches? And so let's take a look at what we'll do. Let's start off with our formula. A equals pi r squared, so radius squared. And so we're going to take that value of pi, and I'm going to leave it as just the irrational, or the exact form. And so again, pi is an irrational number. We don't have an approximate for it, so it continues on forever and ever and ever. And you'll see if I pull up a calculator here, and I just enter or press this pi button, you can see how much further those decimal points can go. So we can approximate it out, way out there. But these numbers never repeat in a pattern. Numbers after the decimal point here never repeat in a pattern, and they never end. And so that's why we call that an irrational number. So in order to show the exact form, we're not going to approximate pi. And so we're just going to leave it with this Greek letter. Pi is how they end up spelling that. But anyhow, we go ahead and take the 5 and we square that number, and we end up with 25 pi. And then our units are inches, so we'll say inches squared. And so this is the exact answer. And later on, you'll see why we use the exact answer. It's more for more involved shapes. And we'll end up using that exact answer to come up with a full, maybe like the circumference or the area or volume of a cylinder. We'll use that exact answer until the end, and then we'll end up approximating it later. And so we need to know the approximate answer as well. And so the approximate is when we take 25 and multiply it by 3.14. And so we'll go ahead and do that on the calculator here. I'll clear this. Again, if you use the pi button, that's fine. It'd be a little more exact, but I'm just going to go ahead and use 3.14, multiply that by 25, and I end up getting 78 and 5/10. So I'll write that answer down, 78 and 5/10 inches squared. And that's just an approximate, so I'm going to use these squiggly lines to show that, and my exact answer here of 25 pi inches squared. Let's take a look at another one. What is the area of a circle whose diameter is 12 inches? So remember, our formula for the area is radius squared times pi. So if we're given diameter, which is 12 inches, I want to find the radius. Well, looking at this picture here, you see the diameter is a chord. Chord's a line that goes through a circle, and it goes through the center of the circle. So it's a special type of chord. It's the longest chord in a circle. Well, the radius goes from the center of the circle to the curve, so it's just half of the diameter. So the radius is going to end up equaling 12 divided by 2, which is 6 inches. So if we're given the diameter, you got to cut that in half to find the radius. So we'll do the same thing. We'll come up with the exact answer and the approximate. So 36 is what I get when I square the 6, and pi, and these are again inches squared. This is the exact answer. And so let's take a look at the approximate answer. We're going to take 36 and multiply it by our good approximation of pi, 3.14. So we'll pull up the calculator, and clear the last one and do 3.14 times by, and then I get 36. And notice it's 113 4/100. So let's write that one down. 113 4/100 inches squared. So just real quick, let's see what the answer would be if I use that better approximation. It's going to be really close. Let's just go ahead and clear this. If I press pi and use all of these decimals here, and then multiply that by 36 equals, and notice it's 113.097. So it made it a little bit bigger because my answer for approximate for pi was a little bit more as well. But you can see how close it is. So let's take a look at another problem here. What is the radius this time of the circle whose area is about, and then they give us this number of 353 86/100. So let's go ahead and write down our formula. It's a little bit different because we're trying to find the radius, but we have the area. So let's go ahead and substitute what we know. We know that the area is 153 86/100. We also know pi, and so I'm going to go ahead and bring down that pi, and I'm going to approximate this as 3 14/100. I'm going to use that. And then radius squared is what I need to multiply that by. So I'm going to solve for the radius squared. So the way we do that is we do an opposite operation. See, I need to undo this multiplication, so I'm going to divide by 3 14/100. And so I'll go ahead and do that on both sides. Now let's go ahead and figure out what that answer is going to be. So let's go ahead and clear this and write in 153.86 and divide that by 3.14. And we get 49. Okay, so let's write that in there. 49 equals r squared. But that's not our answer yet. You see, what we need to do is take the square root. See, the square root are the two numbers that multiply to make 49 that are exactly the same. So I do that, and I get 7 as the radius. So 7 inches is our answer. So this time it says, what is the diameter of a circle with an area of 254 3/400 meters? Oops, these aren't inches. Let's go ahead and change that real quick. Let's do an eraser here, and I'll change these. It looks like I changed my units, and I should have feet there instead. So let's change that to feet. I noticed that because my units here changed, so I figured maybe I changed the units in the last problem. So let's go ahead and continue on. Let's start off with our area formula. Area equals pi r squared. And now we're trying to find the diameter. Well, we first need to find the radius, because the radius is just half of the diameter. So the radius goes from the center of the circle to the curve. So if I double that distance, that's going to give me the diameter. So let's solve for the radius. So let's go ahead and substitute. So in place of the area, we're going to put 254 3/400 equals pi times the radius squared. Now, we know what pi is, so let's go ahead. We're going to divide by pi. But remember, that pi value is that 3.14. So let me write that all out. So 254. Let's get rid of that decimal point there. Let's try that again. 254 3/400. And I'm going to divide by 3 14/100. And this is going to equal the radius squared. So let's go ahead and do that work. So in our calculator, we'll punch in 254. Find the problem there. 254.34, and I'm dividing it by 3 14/100, and that gives me 81. So 81 equals r squared. So the next step is just to take the square root, because I know what the radius squared is, and if that's 81, then the radius must be 9. So 9 meters. But remember, they wanted the diameter. So again, the diameter is double the radius. So what we have to do is take that radius and double it. So I'm going to do 2 times by 9. Again, this is the meters units here. It looks like some sort of number, but that was an M for meters. And so this is going to end up being 18 meters is what the diameter ends up being. Now let's take a look at the next type of problem we'll end up experiencing here, and it's right over here. And it says, find the area of the figure below. So this time we're dealing with a half circle, and we have the diameter because it's going all the way across. Now I know this is the diameter because of this dot right here. So whenever we see a dot that's kind of close to the center of the circle, that must be the center. And if a line goes through that dot, through that center of the circle, and goes from curve of the circle to curve of the circle, we're dealing with the diameter. So let's go ahead and find the area of just a circle. So area equals pi r squared. And we go ahead and substitute our numbers in. Now remember, we're given the diameter. Diameter equals 20. So the radius is going to be half of that diameter, 10 inches. So let's go ahead and substitute our numbers in there. So pi times by 10 squared. So I'll square first, so I get pi times by 100. But remember, I want to find half of this. I have a half circle. And so if I have a half circle, I'm going to take that that circle's area, which is 100 pi, that's the exact answer, and I'm going to divide that by 2 because I want a half the area. And so half the area, I'm going to divide that 100 by 2. So I'll divide this by 2, and so I'm left with 50 pi. See, this is a reason why I like to leave it in terms of pi, because it was easier to divide 100 by 2 than it is to divide 100 times pi and then divide that by 2. So now this is my exact answer, feet squared. So now I want to find the approximate. So I'm going to do 50 times by 3.14 for my approximate answer. And so let's go ahead and pull up the calculator now and clear the last one, and we'll write in 50 times by 3.14. And this is what we end up getting, 157. And then the units are feet squared. So there is our answer. So let's take a look at our next one here. So this one didn't show up so well, but what we've got is a donut pretty much. We've got a circle here, and we are trying to find this filled in region here. And the filled in region is just this outer section right in here. So this is all that outer section. So what we want to do is we want to find out what the area of both circles are, the large circle and the small circle. And then we're going to take away that small circle. It's like having a big circle here, and then we took a drill and we drilled out the center of that, made like a washer. And so what we want to find is the area that's remaining after we drilled out this circle, the center circle. So let's find the area of the large circle, and we're going to subtract the area of the small circle. And so we'll start with finding the area of the large circle. So let's do pi r squared and minus a pi r squared. And so the radius is the part that's different. So we've got pi times by the large circle has a radius of 7. So 7 squared minus, and then the small circle has a radius of 3. So 3 squared, and that's what it says right here, 3. So go ahead and do that work. We get 49 pi, and then we're going to minus 9 pi. See, here's another reason why I like to leave the answer in the exact form to start with, because it's easier to subtract these numbers at this stage. See, all I have to do now is I have to subtract 49 pi minus 9 pi, and that gives me 40 pi. See, if I multiplied out pi times 49 and 9 times pi, that'd be 2 tough multiplication problems and 1 problem. Now I only have 1 tough one, and I just have to do 40 times by 3.14. So this is my exact answer. Again, these are inches squared. So this is the exact answer, and I'm going to find the approximate by doing the 40 multiplied by 3.14. So let's go ahead and do that real quick. So I punch into the calculator 3.14 times by 40, and that gives me 125 and 6/10, and these are inches squared. So those are the types of problems you're going to see on tonight's homework. Good luck.